Okay, so for number 9, they're asking you for the next 4 terms for the common ratio and for both the explicit and the recursive rules for the sequence. So I start off with the ratio. So right here, it's to go from 3 to 15, you do times 5. And so I multiplied by 15 by 5 and just continued that, and I got these numbers. The explicit formula or explicit rule, it's the first number times the ratio to the n minus 1 for all n greater than or equal to 1. And the recursive is f of 1 equals 3. And then f of n equals 5 times the previous term for all n greater than or equal to 2. So for number 10, to get the common ratio, you could put negative 25 over negative 125, and you get 1 over 5 after you reduce it. So you multiply negative 25 times 1/5, and you get negative 5. Then negative 5 times 1/5 gives you negative 1. Negative 1 times 1/5 is negative 1 over 5, and then times 1/5 gives you negative 1 over 25. The explicit rule, this is the first number times the ratio to the n minus 1 for all n greater than or equal to 1. For the recursive rule, you start off with the first term. F of 1 is negative 125. And then f of n equals the ratio times the previous term. And for all n greater than or equal to 2. Okay, because this is 1, this is now 2 right here. Alright, so 11, the common ratio is negative 3. And then you multiply 6 by negative 3, and you get negative 18, and then times negative 3 is 54, and so forth. The explicit rule is this is the first number, this is your ratio to the n minus 1 for all n greater than or equal to 1, and then for the recursive you start off with f of 1, and that's your first number, and then f of n is the ratio times the previous term. This is the expression or the notation for the previous term for all n greater than or equal to 1. Greater than or equal to 2. Okay, so for number 12, I copied up to n is 3 right here because to find the ratio, I didn't want to do 1 over 1/4. So I just wrote the next number, so 4 over 1 is better, I guess less complex, 4 over 1. So that's how I got the 4. So here's the explicit rule. This is the first number, the ratio to the n minus 1 for all n greater than or equal to 1. Now, right here on the side, 1/4 could be written as 4 to the negative 1. Remember that? And so now I have the common base. So I add the exponents. So I end up with this equation right here. So this is also valid. This is fine right here. This is probably the most common one. But if you can see this is actually pretty awesome, because now you could write this and know that it's the same sequence. Okay, it's representing the same sequence right here. And recursive, again, pretty straightforward. F of 1 is 1/4, and f of n is the ratio, which is 4 times the previous term for all n greater than or equal to 2. So for number 13, I just wrote the first 2 terms, and I took 18 over 162, and I got 1 over 9. So that's the ratio. So the explicit rule, here's the first term, 162, the ratio. Now, because it's starting on 0, remember there's another version of this formula. You don't put n minus 1, you just put n up here, because we're starting with n is 0. And so you just write that right here. Recursive, remember, it's f of 0, not f of 1. Why? Because that's my first term right here. So f of 0 is 162, f of n is 1/9 times the previous term, and then because this is 0, now this is 1. That's the next term. Okay, so for number 14, the initial value is 1/2, and so that's why you see that here, 1/2. And the ratio, common ratio is 3, so you multiply 1/2 times 3 over 1, and you get 3 halves. Times 3 over 1, you get 9 halves. Times 3 over 1, you get 27 halves, and then 81 halves. I went ahead and converted them to decimals down here, just because makes it easier to graph. Like you could locate the point. I think you could interpret it easier as a decimal than than as a fraction when you're graphing it. So anyway, for 0, it's 1/2. So it's going to be 1 about here. For 1, it's 1.5, about here. For 2, it's 4.5, so that's going to be about here. For 3, it's 13.5, so it's going to be about here. And the last, the 4 is not going to fit. Okay, it's 40.5. But you can see here, it's an exponential curve. It's not on a straight line. It's exponential. So this represents the amount that Oscar needs to repay on a loan at the beginning of month N. And so it's asking how much is he paying per month. So that's the common difference, right? So that would be this value right here, the -60. So he pays $60 per month. Okay? And then it says, and the month in which he will make his last payment. So that would be when this is 0. When this is 0, then that's going to give us the value for n. Like how long before this amount that he owes is 0. So we're going to set it like this, and then just solve for n. So n minus 1. And so I'm going to move the 900 over, so it's -900. And then I'm going to divide by -60. I could have distributed the -60 also, but this is fine too. So I'm going to get rid of this here, and so the negative over negative cancels, and 6 goes into 90 15 times. Let's change the color. So 15 equals n minus 1. So then we add 1. So that's the 1 right there. So 16 equals n. So that means that he will pay, or he will make his last payment on the 16th month. Okay, and then that's it. Alright, so the common ratio here, from you put -12 over 3, you get -4. The first term is 3, and then we are adding 1, 2, 3, 4 terms together. So it's going to be sum of 4 equals the first number times 1 minus the ratio to the 4th power all over 1 minus the ratio. Oops, 4. I'm already thinking of the answer. So here I'm going to put 3, 1 minus, and -4 to the 4th power is going to be 256. And then 1 minus the -4 is actually 5. So then that's 3, -255 over 5. And so 5 goes into 255, -51 times, so that's going to be -153, my answer. So the common ratio in this series right here is 4. The first term is -2, and we are adding 1, 2, 3, 4, 5 numbers together. So the sum would be the first number times 1 minus the ratio to the 5th power over 1 minus the ratio. So that's going to be -2, 1 minus, excuse me, 1024. That's what 4 to the 5th is, over -3. So that's going to be -2 times -1023 over -3. So negative over negative is positive. And so that's -2 times 341. So that's going to be -682 as my sum. So we have to find the number of terms in the series and then find the sum. So I can't get these three values right now because I don't know what this one is for this particular series. So I'm going to go ahead and do the explicit form, or the explicit rule. First number times the ratio to the n minus 1, and replace f of n with 256. So 256 equals 1 times 2 to the n minus 1. So I could just get rid of the 1, right? Divide by 1 is the same thing. So 2 to what power gives you 256? As it turns out, 2 to the 8th power is 256. So that means that 8 equals n minus 1, so that means that n is 9. So there are 9 numbers that we're adding together. So we're going to do s of 9 equals the first number times 1 minus the ratio to the 9th power over 1 minus the ratio. So 1 minus, now 2 to the 9th power is 512 over 1 minus 2, negative 1. So negative 511 over negative 1 is 511. So right here on number 19, the common ratio is 3. And again, we don't know how many terms we're adding together. We have to find that out first. So we use the explicit rule, which is right here. The first number times the ratio to the n minus 1. And so this here becomes this number right here, the last term. So we're going to put it right here. And then now the next thing is I'm going to do is divide by negative 3. Okay, so we're going to cancel that. And so negative 59,000 is divided by negative 3 is 19,683. 683 equals 3 to the n minus 1. So again, doing guess and check and just trying different powers of 3, it turns out that 3 to the 9th power is equal to 19,683. Okay, I don't know what's happening with the pen. And so that means that 9 equals n minus 1, so n is 10. Okay, n is 10. So now I find the sum of the 10 is the first number times 1 minus the ratio, which is 3 to the 10th power over 1 minus 3. So that's negative 3, and denominator is negative 2. So 1 minus 3 to the 10th is 3 to the 10th is 54,049. And so we're going to divide it by 2, so we're going to get, by negative 2, so we're going to get, 59,000. So we get negative 3, let me write it here, negative 59,048, because remember how we have to subtract it from 1. So this is what you get. So it's negative 3, positive 29,524. And so you multiply by negative 3 and you get negative 88,572. And that's the final answer. So the two answers here are n is 10 and the sum is negative 88,572.